I'm pretty sure every one of you has had a moment like this. A car speeds past you, just this close, or maybe you slipped and nearly smacked your head on a running chainsaw, and you thought, holy crap, I could die. Well, it's a real story from my life. When I was a kid, my family went on a cave tour. I had the camera in my hands, staring into the pitch black screen and didn't see the huge hole in the ground. And yeah, I fell in. I'm not so smart, I know. When they brought me back home, not a single scratch. But for real, I could have died. Or maybe I did. Okay, it's time to talk about quantum immortality. I'll do my best to explain something insanely complicated in a way even someone like me can get it. Trust me, this isn't something you can explain in 2 sentences. So we'll need to break it down step by step. Let's start with the famous thought experiment, Schrödinger's cat. Some of you might not know it, and the ones who do, go ahead and wipe your memory, because this story is too good to not hear again. Here's how it goes. There's a cat locked inside in a box. Inside the box, there's a tiny bit of radioactive material. There's also a Geiger counter. Hope I said it correct. This device detects radiation. The Geiger counter is wired to a hammer, and underneath that hammer is a glass vial filled with poison. Now, radioactive decay is completely random. It might happen or it might not. So it's 50-50 chances. If the atom decays, the Geiger counter picks it up, triggers the hammer, breaks the vial, and the cat dies. If it doesn't decay, the cat's still alive. But here's the weird part. Until we open the box, we don't know
what's in the fucking box,
whether the cat is alive or dead. So from our point of view, it's both. Boom! Exposed. The cat is alive and dead at the same time. This is a thought experiment created in 1935 by Austrian theoretical physicist Erwin Schrödinger. You have probably heard the story before, but it's not just some quirky science tale. It's one of the most important concepts in the quantum mechanics. Did you know there are actually many different worlds? There's micro world, the macro world, and even the mega world. The macro world is the one we all know. My camera, my hand, my body, my house, even Bigfoot, if it's real. The mega world is the big stuff. Planets, solar systems, galaxies. Serious business, no? But the micro world, oh man, there's where things get really weird. Atoms, molecules, tiny things way smaller than everything we can see. And here's the crazy part. In our everyday world, stuff behaves in a very illogical way. It's Newton's laws, physics, cause and effect. But in the micro world, those rules goes out the window. It's like chaos in there. We walk around thinking that everything in the universe follows the same rules we're used to. Cars move, planes fly, gravity works. So when we hear that classical physics doesn't apply somewhere, we think it's magic or nonsense. But it's not. That's exactly what quantum mechanics try to explain. The science of how things behave in the micro world. And once you realize that everything happening down there is scientifically proven, it gets kinda creepy, right? But also kinda awesome. Here comes the hard part. As the physicist Richard Feynman once said, if you think you understand quantum mechanics, you don't. And he wasn't wrong. Back in his days, nobody really understood it. But I'm gonna try to explain it to you as simply as I can. So here it goes. In quantum mechanics, things exist in something called superposition. What does that mean? Okay, imagine this head. You see it, right? Now imagine this room in quantum system and the head in superposition. That means the head is in multiple positions at once. It's lying here, it's floating over there, it's turned upside down at the same time. It sounds insane because we're not used to thinking like that. But in the quantum world, these rules actually apply. Now replace the head with something like an electron or a photon, particles smaller than atoms, and welcome to the madness. Here's the twist. As soon as we try to observe or measure them, boom! The superposition collapses. Suddenly, the head is only in one place, just one, right there. Wild, right? It sounds ridiculous, but it's how quantum mechanics work. Observing the quantum world alters the quantum world. We don't see the actual particle. We see what we did to it. But what does observant even mean? That question haunted me for a long time. Right now, I'm looking at this camera. You're looking at me through the screen? That's observation, right? Well, not exactly. In quantum mechanics, I remember watching this kind of show once, the one with Morgan Freeman. He said that when we look at a photon, we change its path. And maybe really itself isn't even real, but something we shape just by looking at it.
This suggests that we can change the way reality behaves just by looking at it. Does this mean that reality itself is not real?
He said it based on a famous double-slit experiment, which you are seeing on the screen right now. Here's how it works. When we shine light through two slits, photons behave like waves. They spread out, overlap, create interference patterns, super weird. But a second, we start measuring which slit each proton goes through, and wave pattern disappears. Suddenly, we get a normal logical result. No weirdness. Stop measuring again, boom! The weirdness returns. This led people to say reality isn't real. We are living in a matrix. Conspiracy theories everywhere. But here's the truth. The photon isn't some ninja trying to hide from us. We are just messing with it by measuring it. Now here's the big question. Why can one object exist in multiple states at the same time? There are several interpretations of quantum mechanics, and before we get the idea of quantum immortality, finally I need to tell you about them. Just so we are clear, there are still hypotheses, meaning they are just different ways to try to explain what the heck is going on. Let's start with Copenhagen interpretation, which came around 1927. It was developed by Danish physicist Niels Bohr and German physicist Werner Heisenberg. Sounds familiar, right? Walter White named himself after him in Breaking Bad.
Say my name. Heisenberg.
Respect. So the Copenhagen interpretation says this. In the quantum world, particles can exist in multiple states at the same time. But the moment we try to measure them, we force reality to choose one outcome, and all the others disappears. It's like reality flips a coin every time we observe it. Some scientists agree with it, others don't. Personally, I prefer the many worlds interpretation. This one was introduced in 1957 by American physicist Hugh Everett. It says that every time we make a measurement, reality splits. The universe branches off into two or more versions, and we end up in one of them, just randomly. So imagine this. As scientists measure a photon, one universe forms where it behaves one way, another universe where it behaves differently. Two versions of the world with two completely different outcomes. Yeah, it sounds like we're living in a matrix, but actually a lot of scientists support this interpretation, and there is no magic involved. And this is the key to understanding quantum immortality. I know it took a while to get here, but the setup was important. Let's go back to Schrödinger's cat. Remember, we don't know if the cat is alive or dead until we open the box. Now imagine we put a human in a box instead. And instead of vial of poison, there's a gun aimed in the head. It either fires or it doesn't. We don't know what happened until we open the box. So here's the paradox. If the Copenhagen interpretation is correct, then the gun fires and the person dies. The end of story. But if the many worlds interpretation is correct, then with every trigger pulled, the universe splits. In one version, the person dies. In the other, they survive. Now, here's the crazy part. Imagine you are that person in the box, and every time the trigger is pulled, you survive. Because the only version of the universe you are aware of, the one where you didn't die. That means, from your perspective, you are immortal. You never experience death, because your consciousness only continues in the worlds where you survive. Sure, another version of you might die, but you won't be around to care. You'll only keep waking up in the versions of reality where you made it. Just don't go testing this theory, okay? It probably don't work. This experiment is only successful from inside a box. So yeah, you survive every time. In your universe, everything is fine. But in other ones, when the scientists open the box, well, there's your brain everywhere. Creepy? Absolutely. But kind of fascinating, right? it raises a weird thought. What if you truly can't go existing? What if there will always be a version of reality where something happens to keep you alive? And if that's true, then think about this. A long time ago, a little boy fell into the cave. Maybe in that universe he didn't survive. He never grew up, never go into the science, never started this channel. But that was another universe. Look, scientists still don't agree on how all this works, and I'm not claiming to know either. I'm not a physicist. Don't take my word for it. If this stuff really interests you, go read, research, explore, let the scientists figure it out in time. For now, what matters is that it works. And thanks to quantum technologies, we already got some crazy cool stuff like... but, you know, let's have that for another video. Thanks.